This is something called a hand boiler. We're providing it as part of the IOR STEM toolkit. You can use it to demonstrate the principle of Charles' law. Now, Charles' law, named after an 18th century scientist, it explains the relationship between how gases expand when heated. So the statement of Charles' law is when the pressure of a sample of dry gas is constant, the temperature measured in Kelvin and the volume will be in direct proportion. So it's a little bit abstract, so this is a way of making it practical. You've got a sealed container, and in there you've got some ethanol solution. So what you do, you put your hand there and make it warm. So because the sealed container is a fixed volume, as the warmth of your hand, often you have to sort of hold it a little bit, but the warmth of your hand makes the fluid rise up through the tube, supposedly working against gravity. So the longer you hold it, and it does take a little while, the longer you hold it, the more fluid goes up. There's very little base in the base now, and eventually it starts boiling. So you can see the bubbles coming up as if you were boiling a kettle or something, and that continues. That's not just the air coming up, that's the actual refrigerant the actual ethanol boiling. And what's quite fun is that when you let go, it doesn't just fall down like you'd think through gravity it would fall down, but it doesn't, provided you don't make it warm. It stays up there because, again, the pressure, the vacuum is holding it up there. So what you can do then, if you hold it there, make that warm, the top's going to expand and all the fluid drops all the way back down. When you let go, you can see it's empty. So it's a hand boiler. It's made of glass. It's incredibly delicate. It really is very, very fine and delicate. It comes in this little box, and there's some nice bubble wrap to keep it intact. So when you're using this with the kids, you won't be able to really pass it around, I don't think, unless they are older, because it's likely to get dropped and broken. So it's a good demonstration tool. If you want something for them to use which actually demonstrates the same principle, a nice idea is a bicycle pump. So as a bicycle pump, you know, you're pushing the pressurizing the air to get it into the tire, and you often find the nozzles, the metal bits, get really hot. So that's the same principle of pressure temperature relationships. So that's how you use it, and that's the science behind it. And on the Fantastic Fridges website, there is already an animated fridge which explains this, and some information about the bicycle pump thing, and also some information about a demonstration about how water boils at different temperatures when it's elevated up on a mountainside, things like that. So it's all of these principles that are behind the circuit of a refrigeration unit within a fridge. And there are various examples and animations and games related to fridges and related to different states of matter and gas laws on the Fantastic Fridges page. The news section, we're going to be putting some animations as well of Charles' law and some links and history on there. So you can refer your students to playing about with bicycle pumps, which they might have at home, but also refer them to the Fantastic Fridges website, where they can find a little bit more about Charles' law and the gas laws and some ideas about how things work. So hope you find that useful and that you don't break it, because it really is very, very delicate. Okay, thanks.